for what we call a percent effect. So we have a cylinder and it has its radius being increased by 10% and its height being decreased by 20%. We want to see what the percent effect is going to be on the volume. So in general, recall that the volume of a cylinder is usually pi r squared times height. Well, actually it's always pi r squared times height. But here we're going to have an effect occurring. So we're going to find this new volume, and this volume is going to be pi, because it's always pi, but the radius is being increased by 10%. It's being increased by 10%. So if we take 100% and we add on 10%, that means we'll have 110%. So our radius is now going to be 1.1 r squared, because the increase by 10%. Similarly, our height is going to have an effect on it too. It's decreased by 20%. So what would a decrease look like? Well, that would be like taking the original 100% but then subtracting 20%, which means we'd only be remaining with 80%. So the effect on the height is going to be to multiply by 0.8h, which represents a 20% decrease. If you think about it, if you reduce something by 20%, you're retaining 80%. Okay, so now what do we have? Well, we have a volume equals, I can see that the 1.1 is going to be squared here, so we'll have a 1.1 effect being squared. We have a 0.8 from over here, and if you look at the things that I didn't take out, we have a pi, and then we have an r squared, and we have a height. So you'll notice that pi r squared height was exactly what the volume was. So the effect is going to be coming from this calculation right there. So I'm just breaking out a calculator right now to see what this is. 1.1 squared times 0.8 happens to be equal to 0.968. So of course that's a little bit less than 1. How much less than 1? Well, it's equal to 1 minus 0.032. So that means that that minus 0.032, that's a 3.2% decrease. So what was the percent effect on the volume? It's a 3.2% decrease has occurred. Okay, so why don't you try a problem on your own here? I'm going to move it over and see if you can do this problem. Pause the video and slow it down if you need to. See if you can get a rectangular box having its length being decreased by 10%, width increased by 15%, and keeping the height the same. Okay, so assuming you pause this and tried this, the volume of a box is length times width times height. Length times width times height. So let's calculate our new volume, our blue volume. So our volume is going to have an effect on the length of decreasing by 10%. If you decrease by 10%, that means you will be 90% of what you used to be. The width is increased by 15%, so that means that would be 1.15 of your previous width. And the height just stays the same, so we'll keep that as an h. Now notice that we have, if we were move terms around by the commutativity of multiplication, you can see that we'd have a 0.9, we have a 1.15, and the other pieces would be the L and the W and the H, which is precisely the volume of the original box. So that means that this product right here is going to be the effect. So 0.9 times 1.15 yields the number 1.035. This one's actually a little bit easier to calculate than the other example. That's 1 plus 0.035. So this time our effect was a 3.5% effect, and this time it was an increase because it's greater than 100%, greater than 1.